A cosmic bullet, a planet-shattering collision, the ultimate endgame. It begins with a flicker, a tremor in space. Something is coming, fast, heavy, and unimaginably dense. At first it's invisible, hiding behind veils of distance. Then, astronomers detect the impossible. A neutron star, a stellar remnant more massive than our sun, but only the size of a city, is on a direct course toward Earth. This isn't just another asteroid. This is the corpse of a dead star, racing through the cosmos at a fraction of light speed. It's not burning, it's not glowing, it's simply devouring the space around it with gravity so intense it bends reality. And now it's headed for us. So, what happens when a neutron star hits Earth? Let's be clear, it wouldn't even need to hit. Just passing close within a few thousand kilometers would be enough to destroy our planet entirely. Gravity doesn't play fair, especially when it comes from an object with a mass greater than the sun packed into a sphere only 20 kilometers wide. The approach alone would rip Earth apart. First, the tides would rise not by meters, but by mountains. The moon causes ocean tides because of its mild gravitational pull. Now imagine a gravitational force 1,000,000,000,000 times stronger closing in. Earth's crust would begin to crack. Volcanoes would erupt globally. Tsunamis taller than skyscrapers would wipe out coastlines in hours. Cities would collapse, not from the quake but from the warping of the planet itself. The core of Earth would begin to shift. Our magnetic field, already fragile, would shatter. The sky would glow with strange auroras, not from beauty, but from the breakdown of our atmosphere. Satellites would fail. GPS would stop. Communication would vanish. Within days, Earth would no longer be Earth. And then, if the neutron star didn't just pass nearby, but actually collided with our planet, there wouldn't be a collision in the traditional sense. There'd be annihilation. Earth would be torn into 1,000,000,000 fragments before it even touched the surface of the neutrons. Our planet's mass would be shredded by gravitational tidal forces so extreme, even atoms would begin to lose their structure. No mountain, no ocean, no city would survive the approach. The entire planet would spaghettify, stretched and stripped into an accretion disk spiraling around the neutron star like a glowing, hellish ring. The energy released by this interaction, beyond comprehension. Imagine every nuclear bomb ever detonated, then multiply that by billion. The skies would erupt with X-rays and gamma radiation, blasting across the solar system like a cosmic scream. Planets nearby, Mars, Venus might even feel the ripple. And the sun, it would simply observe, helpless, because against a neutron star, nothing can stand. What about survival? There is none. No shelter could protect against this. No bunker, no spacecraft. The gravitational gradients would twist steel, liquefy rock, and boil the very concept of safety. Even escaping to space wouldn't help. The neutron star's gravity would yank anything within millions of kilometers into its deadly spiral. But let's stretch imagination one step further. What if somehow we survived? A fragment of Earth ejected before the final we'd drift in space, aboard a broken shell of our former world, orbiting the star that killed us, watching, waiting, floating above a death we never truly escaped. Neutron stars are reminders of how fragile we really are. Born from supernovae, these stellar corpses are the densest objects in the universe, aside from black holes. A single teaspoon of neutron star matter weighs about 1,000,000,000 tons. You could never touch one, it would fall through the crust of Earth like a bullet through paper, all while warping time and bending light around it. Thankfully, no known neutron stars are on a collision course with us yet, but in a universe 13.8 billion years old, filled with billions of galaxies and trillions of stars, the odds are never truly zero. And if it ever happens, we won't see it coming. We won't even have time to scream, just silence, and then nothing.